Hello, and welcome back to another episode of the Message from Deep Space. I believe we are on week, 17? I'm Alex Rose, aka Safety Dead, and last time we started talking about chemistry. So last time we started talking about the periodic table, and I was confused why the periodic table lined up with our periodic table. I assume that there's a good reason for that, and I assume that we will find that out. It feels like the kind of thing that would be odd to not come up in this game. But I took a look at what some of our hypotheses were from our teammates about what this second thing could be, and I think I'm going to take Dr. Aker's suggestion, and I'm going to go ahead and I'm going to call that an atom for now. So element to refer to the concept, atom to refer to a specific instance. I guess that makes sense. Atom. What do you need? No, I said atom. The dictionary. Look. Oh. Ooh, if we could talk about atoms with the aliens, then maybe we could talk about the real world. Let's see. So, we've got a new, pretty simple signal, but let's see what we can make of it. So this says unknown A is made of several atoms. So it's asking what makes unknown A, and the answer is atom does, and that would probably make our new signal here a molecule, something that is made of multiple atoms. Molecule? Like one instance of a chemical compound. I think I see what Dr. Rose is seeing. The elements are describing substances by their atomic makeup. Yeah, that's what I'm saying. Uh, their atomic composition. So molecule 0 uses atom 1. And atom 1. So these are two atom 1. So this is two hydrogens. Molecule 1 uses atom 2. And that's it. So that would just be helium. Molecule 2 uses atom 6. I need a periodic table for this. Pop back over to chemistry. Atom 6 and atom 8. So this is two carbons. So this is carbon dioxide. Molecule 3 is oxygen or carbon. So I believe that is just carbon. I don't know what that one's called. And then atom 7, two atom 7s is a nitrogen compound. Okay, lots of stuff. So we're saying one molecule with 6 atoms, one count, equals which of these molecules uses 6 atoms? Is that what you're asking? 1, 2, 3, 4. 1, 2, 1, 2, 1, 2, 1, 2. None of these use 6 atoms, as far as I can tell. So maybe they're asking us about a particular chemical compound. So, do we need a legitimate chemical compound? So, for example, helium doesn't bond with anything. This is going to be our rules for chemical bonding. So there's covalent, ionic, and metallic bonds. Covalent bonds share electrons. So for example, hydrogen, H2O, is water. And the electrons supplied by each hydrogen atom is shared amongst 3 atoms. Ionic bonds share electrons where one atom nearly completely takes or gives an electron from the other. So in this case, sodium chloride, sodium's singular valence electron can be shared in the chemical bonds taken by chlorine. And metallic bonds consist of free-moving electrons that move from atom to atom. For example, iron, in pure iron, electrons move freely from atom to atom. So let's see. We have carbon dioxide. Yeah, okay, here. And then ammonia. So we're defining a few common compounds here. So which of these might have 6 atoms? So rust has 5, 2 iron and 3 oxygen. Aluminum has 5. Copper oxide has 3. Potassium nitrate has 5. Sulfuric acid has 7. Methane has 5. Ethane has 8. Propane has 11. Oh, these are getting quite big. Might have missed one. So let's see. Carbon, this is 3, 4, 2, 3, or 1, 2, 3, 2, 4, 1, 5, 1, 5, 1, 2, 3, 2, 5, 3, 2, 5, 8, 11, 18, 8. None of these have 6. Will they accept just like a made-up compound? So, do we have any perhaps rarer compounds? So, 1, 2, 3 hydrogen and 1 nitrogen makes what? 3 hydrogen, 1 nitrogen makes ammonia. Yeah, so these are some common compounds, and they're listed out here. They're asking us, presumably, for some common compound that has 6 elements. Now, I thought you could make copper or carbon rings that had 6 things in there, so we could try that. So we can say 1 molecule, 6 atom, 1 count. Okay, carbon is element 6. So atom 6, atom 6, atom 6, atom 6, atom 6, atom 6. I don't think it's gonna work. Nope. Okay. I can't help but just feel like I am missing something. Do our teammates have any ideas on this one? No, they do not. Right, so if it's not a matter of something with 6 atoms, then what is it a measure of? Okay, let's review. So we're given a molecule 0, molecule 1, molecule 2, etc. And here we have, this could be molecule 6, atom 1, count. So in that case, if we look at molecule 6, atom 1, atom 1, count, how many times do we use a helium or a hydrogen? which should be 1, 2, 3, 4, 5, 6, 7. So this seems unlikely, but let's just make sure that we're not looking for a count of how many atoms we need. So we'll do 1 up and 1 down, just in case we have miscounted how many hydrogen are available here. Nope. Okay, we have not miscounted. So that I'm returning to thinking that there is something here that we just missed. So 3, 4, 2, 1, 2, 3, 2, 4, 1, 5, 1, 5, 1, 2, 3, 2, 5. I got really excited about this. No, this is still 7. This is still 3, 5. What? What is it asking for? I feel like a molecule with 6 atoms, 1 count. So, is this... It's not asking for a... Is it asking for a count? Is it asking how many molecules have 6 atoms? So that'd be 0. No. Is it... what is it asking for? So here we say that atoms make molecules. And they say, okay, we understand that you know that atoms make molecules. So now, tell us something. Okay, so we have, just to review, our list of molecules. We are starting with dihydrogen. Then we have helium. Then carbon dioxide. Then just oxygen. And then nitrogen? What do they call these two nitrogen together? Perhaps that's a reference we could use. Nitrogen gas. Fitting. And then we have ammonia, which I believe is the 3 helium to 1 nitrogen. Wait. Or they might be asking for a molecule with 6 atom ones. Okay, that could be ethane, which would be atom 6, atom 6, atom 1, atom 1, atom 1, atom 1, atom 1, atom 1. Now, we might need to reverse our atoms 1 and 6. Okay, let's try reversing. So let's take our 6s at the end and put our more plentiful hydrogen atoms first. No signal change. Okay. That was my best guess. But let's look at the formatting again. 1 molecule, 6 atom, 1 count is how I'm reading this. But let's remove the new line from atom. See if that does anything for our understanding. Okay, so this is saying molecule 6, atom 1, atom 1, atom 8. Molecule 6, atom 1 count would just be 2 atom 1s. So that would just be 2. Okay, we were massively overcomplicating it. Okay, I think I do like the new line more on the whole, even though it was messing me up. But you know, let's maybe try the new line before. And let's also put a new line for molecule. Okay, so molecule 0, atom 1, so that's our hydrogen gas. Molecule 0 is 2 atom 1, so that is a chemical compound naming structure. Chemical 1 is atom 1, atom 1, atom 7, so we can say 3 atom 1, 7. And then this is 2 atom 1, atom 8. And we should put that in a parenthetical. All right, understood that one, no problem. Okay, molecule 0 is 2 atom 1, 2 atom 8, and an atom 20. All right, so molecule 1 is 2 atom 1, 4 atom 8, and an atom 16. So it wants to know if it's bigger or smaller. Now that I know that we are talking about atoms, I would guess they're going to be asking about the weight of each atom. Or the atomic mass here. So in this case, our atomic mass of atom molecule 1 is going to be 2 plus 2 atom 8s, which is 16, so 18, and an atom 20. So we're looking at 18 plus 40 is 58. And here we are looking at 2 plus 4 atom 8s, which would be 32, which would be 34, plus an atom 16. The atomic weight of 32 is 48. So this is 48, this is 58. Then molecule 1 is smaller than molecule 0, so molecule 0 is bigger. Well, I mean, we know it's smaller then. Perhaps we did our math wrong. Okay, so molecule 0 consists of an oxygen, molecule 1 consists of 2 oxygen, molecule 0 added to molecule, adding one molecule 0 is one molecule 1, molecule. Okay, right. So we can combine molecules to make bigger molecules. So if we take a molecule 2 and we add one molecule 2, which consists of a atom 7, then we get a molecule 3. Okay. Molecule 0, 2 atom 1s. It'd be nice if we could format atom 1, atom 2, etc. as their periodic table element, but alas. Okay, molecule 0 adding 1, molecule 5. So molecule 0 is 2 atom 1s, molecule 5 is 2 atom 8s. Are there anything that consists of 2 atom 1s and 2 atom 8s already? Yes. No. Because molecule 6 does not have 2 atom 8s, it just has 1. So we can try listing out the full formula. Or wait, no. This is saying it's equal to 2 of something. So since we have 2 atom 1s and 2 atom 8s, we can find something that has 1 atom 1 and 1 atom 8. Right? Because it want as far as I can tell, this is the only thing with 2 hydrogen and an oxygen, or with a hydrogen and an oxygen at all. I guess we could try it. Maybe there's some chemical reaction I'm not understanding. I guess there's a chemical reaction I'm not understanding. Don't like moving forward when I don't have a solid understanding. Okay. Molecule 0 consists of atom 11, molecule 1, 2 atom 17s, molecule 2 consists of what? If we consider that molecule 0 adding 1 molecule 1 equals 2 molecule 2. So atom 11 and 2 atom 17. Can we just say those two together? 2 atom 17 atom 11? No. Unless we need to reverse it. Always try reversing. You never know when you're gonna do Ricky Bobby Proud. No. I'm gonna think on this one. I actually did take a quick break, so I'll be right back when I continue filming this episode. And we're back. So it looks like while I was gone, Bautista started going crazy. He hit us with the bleep bloop. What? You said something? No. Huh. Okay then. Why do you deny your bleep bloop, Bautista? Okay. So we have a molecule, the atom 11, and a molecule with 2 atom 17s. And when we have molecule 2, we need to figure out what it is. um, where molecule 0 adding 1 molecule 1 equals molecule 2. And we have tried the arrangements of molecule 0, molecule 1, where we have 1 atom 11 and 2 atom 17. But that's not correct. We have not tried atom 11, just atom 17. Okay, so for some reason, our second atom is not necessarily turning into 2. It might be because there's only enough of a bond to bond 1. And this isn't just strict addition. So here we have a molecule with atom 26 and 3 molecules with 2 oxygen. We add them together and that equals 2 molecules with 3 atoms, 3 oxygen and 2 atom 26. So it seems like we need to describe a... No, okay. I assumed that we would need to describe having 2 molecules with atom 26 because this is 3 molecules with oxygen. But it might not be 2. It might need to be more, such as 4? Okay. I am curious to see what they said because they might be able to articulate what I'm thinking better than I am. We need to balance this equation. Balance? We need the same number of atoms on each side of the equation. So let's take inventory. How many atoms are currently on each side of the equation? On the left side is 3 molecules with 2 atom 8, totaling to 6 of atom 8. And on the right is, let me see, we have 2 copies of a molecule with 3 atom 8 and 2 atom 26. Which means the right side has 6 atom 8 and 4 atom 26. Math is good. Okay, that makes sense. So now we have 2 molecules with 2 helium, or hydrogen, 1 molecule with 2 oxygen added together equals 2 molecules of what? So 2 molecules where we have, so we've added 4 hydrogen and 2 oxygen, which means that we're going to have 2 hydrogen and 1 oxygen. So 2 atom 1 atom 8. Okay, I'm learning chemistry. All right. So we have a new word now. So, do the unknown A treatment. Okay, so this is a label. So molecule var 0, molecule var 1 equals, or has something with unknown A that results in molecule var 2. So maybe this is some sort of react word? Molecule var 0. Molecule 0 with 2 out of atom 1. Molecule 1 with 2 of atom 8. Molecule 2. 2 atom 1 and 2 atom 8. So Molecule 3 is 2 of atom 1, 2 of atom 8. Molecule 1, 2. Molecule 0. 2 molecule 0 reaction. Two molecule 2. Okay. So if we take molecule 1 and 2 of molecule 0, so 2 of atom 8 and 4 of atom 1, then that reaction should give us molecule 2 with 2 of atom 1 and atom 8. Now if we have molecule 3 reaction, two molecule 3 reaction, something molecule 2. Now, here we're given 2 molecules to react with each other, whereas down here, we are only given molecule 3. So, if we are taking molecule 3, which is this 2 of atom 1, 2 of atom 8, then something produces 2 of molecule 2. Which would require an imbalance where we add more hydrogen. To molecule 0? No. What? To molecule 3 reaction. So, molecule 3, which is, we do atom 1 and atom 8. We have 2 of these and 2 of these. So what happens here to result in molecule 2, where we have 2 of these and 1 of these? We could subtract molecule 1 but we don't have any precedent for it being a subtraction. But we are doing some kind of subtraction. So this, if the reaction happens afterwards, we combine them. But we can also react in order to split things off. Okay, molecule 0, atom 11. Molecule 1, 2 of atom 17. Molecule 2 is atom 11, atom 17. So, how we saw this before is molecule 0, molecule 1 reaction. Molecule, and then this will result in molecule 2. But we in fact need 2 of molecule 0 to balance the equation. And this gives us molecule 2. What is it? What does that mean? What if I made a typo here? Entry not found 0. It's gonna have a tip on the formatting here. No, it is not. Okay, so molecule 0, atom 11. Molecule 1, atom 17. Molecule 2, atom 11, atom 17. Now, we can use... I assume they want us to use reaction, but we could also just use our earlier formatting here. Where we say molecule 2, molecule 1, this probably won't help with the... Yeah, okay. It still says 0 is not found. Why? What happened to 0? You had a problem with 0 a while ago. All I can think of is that I'm spelling molecule, but... Okay, nothing broken there. I'm just adding it piece by piece and seeing at what point it breaks. You may never know. Okay. That's pretty much the one that I wanted to test. So we have 2 of molecule 0, which is our... And then we have 1 of molecule 1. And that would balance the equation to have even amounts of... what are these 2 elements? I wonder if that is relevant. So we're looking at 11 and 17. So we're looking at sodium and chlorine. Salts. We're talking about salts. Okay. So the way that reaction was used previously, perhaps it is not reaction. Well, I mean, I would assume so because the interpretation feels wrong now. So here we have molecule 0, molecule var 1, reaction, molecule var 2. Now, these are notably not separated by a comma. And the way that we use it here, molecule 1 to molecule 0 reaction to molecule 2. So these are also not separated by a comma. And they also balance what the output is. Okay. So reaction equals molecule add, or reaction equals molecule subtract. Yeah, okay. You could have said that first. That would have helped. Okay, and now we have a new signal where we have a collection with an unknown number of molecules and a reaction with a variable number of second molecules equals are unknown. So in this example, we have unknown 0 is atom 1, and atom 1 something molecule 2 atom 1. No, okay, it's not adding those together. Is it our new unknown signal? Or it could also be reaction. Okay, that doesn't clarify what our new unknown is very well. Huh. 4 years at undergrad, 5 years at grad school, nearly a decade with the space agency. Dr. Akers, I can hardly follow along. I'm not following along. Okay. Unknown 0, 2 molecule 0, 2 atom 1, 1 molecule 1. Oh, it just feels like a lot of gibberish to me now. Chemistry was always one of the things that I struggled with the most in school. Okay, so 2 molecule 0, which if we have 2 of this first molecule, which consists of 2 hydrogen, and 1 molecule 1, which consists of 2 oxygen, then the reaction produces 2 molecule 2, which will be an oxygen and 2 hydrogen. And then our unknown. So this actually feels like it maybe better fits a reaction. What is a, let's look at our reference sheet here. So we can say that these are bondings, or this, okay. Formula? Could be formula. Maybe recipe? Okay, so recipe 0 is this. Recipe 1, we take 2 molecule 2s, which are the dihydrogen monoxide, and we split that as a reaction into the original recipe, which is 2 hydrogen and 1 oxygen. So statement, recipe 0 equals recipe 1. True. These are not true. So 2 out of 1. So they don't consider this to be false, or to be true. They consider this to be false. But why? So here we have 2 sets of hydrogen gas and 1 set of oxygen gas. And then we're saying that we split from 2 dihydrogen monoxide into 2 sets of hydrogen gas and 1 oxygen. But these are not equivalent. But I don't know if they're saying that those don't balance in a way that I'm not understanding, or if those are instead... The aliens want us working with Adam too, huh? Takes me back. To where? Grad school. Berkeley, was it? What was your research? Mapping space with radio astronomy. The element 2 reaction. Not, therefore, atom 2 reaction. Not. Element 2 reaction, not, therefore, molecule. Something atom 2. Oh, what's going on, Acres? In grad school, I worked every night at the Leshner Observatory, recording waves, charting the skies, and in the daytime, I'd dig through the data, piecing together trends and searching for anomalies, day and night on research. Not much time for a social life? I'm afraid I can relate. I as well. Bautista, I'd reckon your lack of friends began long before grad school. Which one of us is married? You're married, Bautista? 15 years strong. Well, good for you, Bautista. Guess there's hope for people like me. No, there is not. So, element 2 reaction, not. Therefore, molecule can only have one element 2? Dr. Akers, what is radio astronomy? You mentioned it in your graduate research. Ah, yes, the universe is full of electromagnetic radiation, like light waves. Only problem is the frequency of most of those waves is beyond the visible light spectrum. So our eyes can't really see most of the information out there. So you'd look for the invisible part. Yep, like the hydrogen line. Hydrogen atoms change state and release relatively harmless radiation. And when they release this radiation, it's at the same exact frequency every single time. The aliens were clever for picking that frequency as the basis for all their transmissions. With hydrogen's overwhelming abundance across the universe, it's plain brilliant. And the consistent frequency makes it universal. It's the perfect way to say hello. Okay, suppose that element var 0 reaction not. Therefore, collection 17 consists of element var 0. Collection 17 consists of element 2, var 1, var 2, var 3, var 4. So here they're asking us about what the noble gases are. Lucky I know this, but it makes me worry that they're going to ask for more complicated concepts that I don't know. So here we have 10, 18, 36, 54, and 86. No, okay. 5. Okay, they only asked for 4. So, element 2, var 1, var 2, var 3, var 4. Perhaps only down to xenon? No, okay. Someone's got an idea. Now, var 1, var 2, var 3, var 4. Element var 0 reaction, not. Therefore, collection 17 is element var 0. And collection 17 consists of element 2, 1, 2, 3, and 4. Or var 1, var 2, var 3, var 4. Said that there was an idea, and yet I don't see one. What's that? Okay, so what? Where'd the idea go? Is it in the log? Um, no, it's not. Okay, so if it's not there, so we have 4 elements here. 1, 2, 3, 4. And it's not 10, 18, 36, 54. And that is definitely 10, 18, 36, 54. And why are these all stacked on top of each other? Barium, strontium, okay. Now radon is a noble gas. Are we being invited to skip one? Let's see. Do we have anything that speaks specifically about the concept of noble gases? No? Okay, well, what if we look at specifically the helium? No mention here. So, element var 0 reaction. Not. Therefore, collection 17 is element var 0 that doesn't react. Is an element that doesn't react. And here, I'm assuming that it wants to list all the elements that don't react. But we're missing something. I am going to mark these all as red. Okay, wait. It does seem like we were missing something. What is this transmission saying? I'm quite stumped. If an element doesn't reaction, then we can put it in collection 0. I can parse out the grammar of it, but I'm failing to see the meaning. Carrie, what you said makes perfect sense. If an element doesn't reaction, it's noble. Noble, refreshment. Noble elements don't react, so they don't form molecules with any other element. Gotta respond with the other noble elements, which all belong to group 18, the rightmost collection of the periodic table. But I am doing that. Oh, silly me. I need to specify that these are elements. Ah, I wonder why it didn't want the last noble gas. Now I'm reminiscing about my days at grad school, down at the observatory. Oh yeah? We'd only listen in for one frequency at a time, which is what our satellite dish was made for, amplifying large wavelengths. But I always found ways to analyze the interference to derive additional frequencies. So you could get more data out of it? Right! Then we'd adjust the scope's angle ever so slightly, and then for the next night, and repeat the sweep. Snapshot by snapshot, I listen to the fundamental emissions of hydrogen. The hiss of the universe. I listen for light we cannot see, and I try to make some sense of it. The hydrogen emissions, trying to make sense of it. Sounds all too familiar now, huh? I bet you feel at home here, Dr. Akers. Ah, you'd think. I think you're doing a great job, Akers. Okay. Atom equals element count 1. Atom make a molecule. Recipe. Molecule something and then reaction molecule. Yeah. So some amount of molecules on one side, some amount of molecules on the other. My research was mapping out the Milky Way. We knew its rough shape and size well before the early 60s, but my principal investigator wanted me to map it in detail. We surveyed the galaxy's spiral arms, their densities, the rate of rotation, how they would all undulate independently, and the part that gets me going, their elemental composition. How large was this project? How long did you work on this? 4 years. Every day. That was my life. Adjust the telescope, record data, analyze. It was a slow, tedious, and highly granular process. Complex tasks, one step at a time. With a fine-tooth comb and an eager eye. It's the same story here. Only the stars have come to us. Okay. Atoms make up meteorite. Atom make meteorite. And atom make aliens. Atom make humans. And we're all made of the same stuff. Oh, that's another week. What's new? We've learned about molecules, which are atoms that have been bound together, and they have also honed in on one element in particular, helium. Helium? Why? Akers, chime in here. You know way around the periodic table better than the rest of us. Helium's the second element on the periodic table with only 2 protons. The helium atoms are tiny, very abundant, second only to hydrogen atoms across the universe. And they're noble. Noble? My chemistry's not the best, I could use a refresher. Noble means nothing will react with it. Helium atoms never react or form compounds, just like the rest of the other elements in group 18. Helium, neon, argon, and I think krypton's next. It's a pretty unique featuring among the elements. Wait, that list of elements, that list is familiar. Let me check my notes. Oh my goodness, Akers, you're a genius. 3 transmissions ago, those elements were listed together. A good find, you two. But what does this mean? It confirms that element and atom represent element and atom. I wish the aliens could see Dr. Rose's dictionary and draw a big fat green check mark across the words we have right. Yeah, but they don't know our language. Of course not. But they're still finding ways to validate our understanding of their words. Validation is rare, so let's savor this. Seriously, Akers, Collins, Dr. Rose, great work. Hi. And Bautista, I still feel bad about the color display this app. Sorry about the miscommunication. And all of you, take care. Get some rest. I'll see you in the morning. 6 o'clock sharp. Understood. Roger. Got it. Oh, I'm feeling a little underprepared to be doing all this science. So we got 3 good new words. I feel like I expected words to start coming faster the farther that we went, but it does feel like they're kind of slowing down a bit. I wonder if that is because we are working through some more advanced topics with the words that we have now, or if that is because we are just on like a temporary slowdown and it'll still get higher. Alan's journal status timid. I managed to help confirm some of our dictionary words in the meeting this week, which feels good, but it was really the brilliance and attention to detail of Carrie that pieced it together. Regardless, I'm glad I helped some. Batista's log. Dear Diary, Doppler put it very well. As is par for the course of Uncharted Discovery, validation is rare, so we must savor our affirmed triumphs whenever possible. Doppler's report. Dot dot dot. Rose's thoughts. I do not miss balancing chemical equations from high school and college. Hope we find a way to do this easier. All right. So that was another good week. If you enjoyed, don't forget to like and subscribe, and I will see you in the next one.